Hey everyone, welcome back to SyntaxGrid. In the last video, we covered the basics of K-means, what it is, how it works, and its role in machine learning. If you missed it, make sure to watch that first. The link's provided in the description below. In this video, we'll quickly go over 3 important things: how K-means compares to other clustering algorithms, real-world applications of K-means, and its key pros and cons. Let's dive right in. Before we compare K-means with other algorithms, here's a quick view of how clustering methods are generally categorized. Partition-based, like K-means, where data is split into fixed groups. Hierarchical, builds nested clusters in a tree-like structure. Density-based, like dbScan, which forms clusters based on data density. Clustering, as an unsupervised learning technique, helps us group similar data points when we don't have labeled data. It's used in things like customer segmentation, anomaly detection, and pattern discovery. Alright, now let's see how K-means compares with other methods. 1. Differences between K-means and other clustering algorithms. Let's compare K-means with 2 of the most common clustering techniques: hierarchical clustering and dbScan. K-means versus hierarchical clustering. K-means needs you to specify the number of clusters, K, upfront. Hierarchical clustering doesn't. It builds a cluster tree, and you can choose how many clusters you want later. K-means is faster for large datasets, while hierarchical is more interpretable but slower. K-means versus dbScan. dbScan groups data based on density. It's great for detecting irregular shapes and outliers. K-means assumes clusters are round and similar in size, which doesn't always work well. Also, dbScan doesn't need a fixed K value. It figures out clusters on its own. So, while K-means is fast and simple, other algorithms might be a better fit depending on the shape and noise in your data. 2. Real-world applications of K-means. Now let's talk about where K-means is actually used in the real world, and you'll see just how versatile it is. Customer segmentation. Businesses used K-means to group customers by behavior, demographics, or purchase patterns. This helps in designing targeted marketing campaigns and improving customer experience. Image compression. It reduces the number of unique colors by clustering similar pixels. As a result, you get smaller file sizes with minimal visual quality loss. Great for storage and web optimization. Anomaly detection. K-means can flag data points that don't belong to any clear cluster. This is useful in fraud detection, network intrusion monitoring, and quality control. Market basket analysis. Retailers group products based on what customers tend to buy together. This helps in shelf placement, cross-selling strategies, and personalized recommendations. As you can see, K-means shows up in everything from marketing to cybersecurity, often working quietly behind the scenes to make things smarter. 3. Pros and cons of K-means. Let's finish up with the key advantages and limitations of K-means. This will help you decide when it's the right tool to use. Pros of K-means. Simple and easy to implement. It's intuitive and doesn't require a lot of parameter tuning. Fast and scalable. Works efficiently even on large datasets. That's why it's popular in production environments. Widely supported. It's available in almost every ML library, like Scikit-learn, making integration seamless. Works well with clearly separated clusters. If your data is clean and the groups are distinct, K-means delivers solid performance. Cons of K-means. You have to predefine K. Choosing the right number of clusters isn't always obvious and may need trial and error, or metrics like the elbow method. Assumes clusters are spherical and similar in size. It struggles with complex shapes or clusters with very different densities. Sensitive to outliers and noise. Just a few extreme values can pull the centroids and mess up the results. Random initialization can affect results. Different runs can give different outputs unless you use techniques like K-means++. In the next video, we'll jump into the code, step-by-step implementation, and applying K-means to real datasets, so don't miss it. Also, make sure to check out our other videos on supervised learning, like KNN, Naive Bayes, logistic regression, and more. Drop a like, hit subscribe, and I'll see you in the next one.